Hi, good day to you, Dr. Tay. My name is Alvin Paramasevan from Group 7. I have 4 group members including me. Firstly, Anis will be explaining question 1. Next, Nurul Shafika will be explaining question 2. And lastly, Darwisha will be explaining question 3. So the topic that we have chosen is based on line integral. Before we start, I would like to give a short introduction. Line integrals have many applications to engineering and physics. They also allow us to make several useful generalizations based on calculus, and they are closely connected to the properties of vector fields. There are many engineering applications related to line integrals. For example, they can be used to calculate the length of mass of a wire, the surface area of a sheet of a given height, or they can be used to calculate the work done on a particle as it moves through a force field, or the flow rate of a fluid across a curve. These are just some basic applications on line integral. Alright, without further ado, let's get to the questions.
Hi, my name is Anis Azila binti Arman. So I'm from 2 BEKG S2. So I'm going to present for assignment part 2. Question 1 on line integral. So the question is find the work done if the particle move from -2 4 to 1 1 along the parabola y equals to x squared while subject to the force given. So the force given is Fxy equals to x power 3 yi plus x minus yj. So we want to know how to solve the question. So we go to the solution. So firstly, we have to let or assume x and y as the parameter t. So the path of the particle is represented by x equals to t and y equals to t square for -2 less or equals to t and less or equals to 1, while the given function fxy equals to x power 3 yi plus x minus yj, it becomes or change it to fxt because we have assumed that the x and y as parameter t. So fxt yt equals to t power 3. So where we get t power 3 is because we have assumed that or represented x equals to t. So we just substitute the x power 3 to t. Okay, so we get t power 3 times t power 2i plus t minus t square j equals to t power 5i plus t minus t square j. So this is a new the new equation for the force. So next we can calculate the work done. So the work done can be computed as W equals to integral C f dot dr. So C is curve equals to integrate A to B fx dyt dot dr dt times dt. So from the previous slide, we have known the value of A and B. So the value of A and B is -2 to 1 t power 5i plus t minus t squared j dot I plus 2j dt. So we solve this dot operation and we get integrate -2 to 1 t power 5 plus 2t squared minus 2t power 3 dt. So finally we can just substitute the value of -2 and 1 into the new equation and we can solve the question and we get the answer is 3. So here is the summarize for this line integrals in vector form.
For the next question, which is compute the line integral where C is the upper half unit circle, Rs equal to cos S sin S for 0 to pi and Fxy equal to x plus y. From the question, we can get the information which is C is the upper half unit circle. So we know the draw or the curve of C, so we can get like this. Okay, so for the next step, we need know the magnitude of RS. So before we know the magnitude, we need to do the speed. So how we can get the speed? We just differentiate of RS. So cos S, when we differentiate of cos, will be given negative signs, and sines cos, we differentiate, we get cos. So we just substitute to the formula of magnitude, which is square root of x squared plus y squared. So we know the x squared of speed is negative signs and y is cos s. So substitute the value. So square root of negative signs squared plus cos squared. So sin squared plus cos squared, we know sin squared cos squared is 1. So square root of 1 will be 1. So next step, we just insert the formula. So we know from this, x equal to cos s, y equal to sin s. By the way, we need to multiply by 1, but I just ignore because this is 1. If the value is 10, we need to multiply by 10. We refer to the real formula. So the limit we know from 0 to pi. This 0 to pi. So the limit is 0 to pi cos s plus sin s ds. We integrate cos, we get sin s. We integrate sin, we got negative cos s. So the limit 0 and pi. So we just substitute the limit into this and get sin pi minus cos pi minus sin 0 minus cos 0. We know that sin pi is equal to 0 and sin 0 is equal to 0, and cos pi will be negative 1 and cos 0 is negative 1. So minus 1 minus negative 1 will get 2. So the final answer is 2. That's all from me. Thank you.
So, hello guys, I'm Darisha. Today given a question about line integrals, so I need to solve it. So let's solve it with me. So first, for the question is given line from 10 to 41. So so for the first one, I think I do is picture about it. So I need to how it goes, how it was the coordinate was. So I got this. So then I parameterize it to find C. So to become this, so I want to put out of this, so I put 1 minus t. The same goes for yt. So when I'm expand it, and I got 3t plus 1, and for yt I got t, because the upper one, the down one, times 0 and it equals 0. So from the boundary is from 0 to 1. Next, I compare it. So for ds equals dx squared plus dy squared. So dx squared I got dx I got 3. ds I got 3. For dy I got 1. So that's why the value I put it into this. Okay, so for for x t square, I got 3t plus 1. So square, all of it square. So yt is t. So I square it. And this, I exchange the value. So I got this
and the total is 10. So third 10 is constant, so I put it on to outside. So next I expand it and I got this. When I got this, I make it small, like compare it. So I got this. So when I integrate about it 10t squared and I got 10t at the power of 3 over 3, the new power 1, and 60 and I got 3 t squared plus t. Integral 1, I got t. So this is I already make it smaller. So we put the value from 0 to 1. So for the very 0, I didn't put the value into this, because if you put 0, all this becomes 0. So I put the value of 1 and I got 10 times 1 power of 3 over 3 plus 3 times 1 square and plus 1, and I got 22 over 3 times 16. So guys, this is the final answer of my question. So thank you for listening to me.